Hey guys, it's week number 5 of me doing the Google Data Engineering learning path. I share the whole journey with you, the ups and downs, the successes and the losses, and the goal is to go from zero to eventually finishing this learning path and then completing and passing the Google Professional Data Engineering certification. This week was about building batch data pipelines on GCP. And the course started with an overview of batch data pipelines and their characteristics. So they explained what batch data pipelines are, how they are different from streaming data pipelines. I can't say that this information was new to me because after all, I'm already 5 years working as a data engineer, but it was a solid high level overview of the concept. And also I have a note that the quizzes on this topic were pretty good. Then it covered Apache Spark and specifically with BigQuery. I feel like GCP is leaning towards that integration between Spark and BigQuery, which I think is very good thing because if you follow this channel, maybe you already know I'm a little bit passionate about both Spark and BigQuery and the way how it can all be combined. There are already 2 videos about Spark stored procedures in BigQuery, where you write a procedure, general stored procedure, but you do it in Spark, and it lives in BigQuery and can be run as a scheduled query from within BigQuery and has this nice tight integration with BigQuery. There is also a way to run Jupyter notebooks in Spark in BigQuery. It was also covered. Honestly, I haven't used that in practice yet, but I feel like the time will come and I'll use it. So as you can see, I'm passionate about the Spark plus BigQuery. I think it's super cool. So obviously I like that part as well. Then there was a deeper dive into the data flow and serverless for Apache Spark. Both are data processing tools, and I think it's mostly on your personal preference, whatever you choose, or the knowledge that you already have, because data flow is cool. It's like a service in GCP where you can run your Apache Beam code to do real-time data processing or batch processing, or there is a way to run Spark using their serverless technology where you just submit the Spark job and you don't really care about managing Spark cluster and stuff. Also, I have a note here about Notebook LM AI generated podcasts. If you have watched the previous video in this series, I mentioned there that Google did the whole revamp of their this learning platform. So now it looks different. It's a bit more interactive. So I would say change for the good. And now you can read like this document with the whole information about some topic. It has interactive elements, and this was the new interactive element that I have encountered for the first time during this course last week, which was like an audio file. You can play it, and it's an AI generated podcast covering certain topic within the theme that you are learning about. I have kind of mixed feelings. On one hand, it's nice to have it because it's even more interactivity that they add. But just imagine you are learning some topic, reading this paper, and then all of a sudden there is like an audio file. Okay, you click on it, you start listening to it, and if it's like 6 minutes long, what do? You do just like sit and look straight to the screen, trying to like comprehend what are they talking about. Because me personally, I was kind of distracted when I was listening it, not because it's AI generated, there is nothing wrong with that, but just this mix of formats, like 6 minute audio right inside of the long paper that you read, feels a bit strange to me, but I could change my mind in the future. So not so bad, but something that I have noted separately. Next topic was about the fundamentals, about error handling, data cleaning, and dead letter queues. All these 3 concepts are interlinked between each other, and all of them are very important. So about error handling, there are several ways how you can do it. First of all, if your pipeline encounters an error, you can like do a complete failure, just stop processing, for example, the whole file or the whole batch of records. It's not perfect because of one invalid record, you could get stale data in your downstream reports or something. So obviously, if you have 100K of records and one is beaten, you don't want to terminate the whole process because of it. Or on the other hand, there can be mission critical situations, which is like a minority of them. But yeah, there are cases when you would actually want to terminate the whole process if that happens. Another approach would be to do certain amount of retries and then, for example, skip this record if you fail to process it after a certain amount of times. Or another one, the last approach, if I didn't forget about anything, would be to use dead letter queues. It's like a queue. It can be a pub subtopic in Google Cloud or a storage bucket or certain table, whatever, where you would send the invalid record to and then keep processing the rest of the records which are valid. And the data cleaning comes in between. For example, the record was read successfully, but then you have some validation rules, and that would be a data cleaning part. And if your record fails validation, data cleaning, you separate it from the main batch of records and send it to the dead letter queue and keep processing the validated piece of data further. Moving on, the next topic was about the one of the most common tasks for data pipelines, for data engineers, for what we need to do with the incoming data. Can you guess which task is it? It's a deduplication task. So if you're processing data in batches or even when we stream data, it's one common thing that we have. From time to time, we get duplicates. In this topic, we have learned about the types of duplicates. So there can be full record duplicates. There can be key-based duplicates when the key is the same, but the values in certain columns are different. For example, if you have a batch of events, let's say transactions, and transaction ID can be the same, but event time could be different, then that would be a second type of duplicate, a key-based duplicate. But you have a way to choose the best fitting record programmatically. And the last type of duplicates that was covered was, I don't remember the correct name, but the idea was that these records can have even different identifiers, transaction IDs, keys. But essentially, when you think of them in terms of the actual domain knowledge or like data, the essence, the entity, they represent the same entity. And this type of duplicates can arise when we deal with systems that involve, for example, human in the loop, when someone inputs certain data, I don't know, in the store, in the clinic, or wherever, about some entity. And when we have a human in the loop, it can happen that the person, one person or several people, they input the information about, for example, the same patient record, or the same contact, if we think about the CRM system lead or whatever. So when we have such cases, when it's a duplicate, but it's not that obvious of a duplicate, these are more difficult cases, and you can't really solve them as you would solve the duplicates number one with full row duplicates and number two with key-based duplicates. How do we solve this very common problem? With Apache Spark, which was an example there, we could use window functions. And if you have watched the videos that I did about top 10 most asked SQL questions during the job interviews, The window functions question is definitely one of the most common ones, and this topic is very beneficial to learn because it's present in SQL. As you can see, it's present in data pipelines, in Spark, in other data processing engines, and it's a tool that we can use to fix the deduplication problem, to duplicate records. If you have a full row duplicate, you could use a window function partitioned by all columns and then rank it and select number 1 with the rank. If you have a key-based duplicate, you would partition based on the key, like transaction ID, and order by event time. For example, in descending order to select the latest event and then apply the rank. With this approach, you would always have the consistent results of the duplication in the end. And if we talk about this problematic last type of duplicates, where the records can seem different based on the key and based on the columns, but essentially represent the same entity, the way that these duplicates can be addressed is not that easy. For example, you could have a vectorized version of the records based on the specific columns that make sense. Like if we talk about the customer, that could be ID, I don't know, first name, last name, city, whatever. And how could we have duplicates there? For example, if someone misspelled their name or someone misspelled their surname. And the way to address it would be to create a vectorized similarity search, to create a vector from each record based on the specified columns, and then you would see the records whose vectors are similar to each other, and then based on this threshold of similarity, you could show these records to the human in the loop that would like manually review these entries to find out whether they are actually duplicates or it's like a normal case. And in case of duplicates, then manually this person would resolve the issue and get rid of the duplicates. So that's the way how you would fix this complicated case of entity level duplicates. The next topic was orchestration. So imagine you have these different pipelines, services that do their own chunk of the job. But you need a way to somehow say that first run this to pre-process the data and load it, for example, to cloud storage, then trigger that system that would take it from there, apply some enrichments, extra processing, and load this data to BigQuery. And then once data is in BigQuery, something else needs to happen. And this process of linkage from one service to another service to another service, this workflow is called orchestration. And for that, we have 3 orchestration tools available in GCP. The tool number 1, the most straightforward and simple, is Cloud Scheduler. Essentially, it's a cron tool in GCP where you can specify the schedule, and then this service would go and trigger, I don't know, certain endpoint with HTTP or trigger some other service inside the GCP. Basically, you set the time, you set the frequency there with a cron expression, and that's it. You give it permissions to trigger the other service, and it goes and reliably executes on time as you specified the as a trigger to another service. Very quick, very effective.
Again, we're here. Very quick, very effective.
Another one for more complex workflows is called actually a workflow. It's a declarative way to specify the dependencies of this DAG, this graph, this lineage of services that needs to be executed. And yeah, you can specify it even as a JSON, or if I'm not mistaken, in a YAML format. And it's like more powerful than just a Cloud Scheduler because it covers the whole workflow. Scheduler, on the other hand, just runs on time and triggers one resource that you specify. This workflow file can trigger a bunch of resources one after another and control like this whole workflow, the whole execution, and retry the parts that fail. It's a great tool for low latency tasks. There is nothing huge to provision, so when you need a low latency and kind of complex workflow of execution, then workflows in GCP is the tool for that. Forgot to say, it's especially great for API calls orchestration. The last orchestration tool covered in GCP, the powerhouse of orchestration for data pipelines, is Cloud Composer. And Cloud Composer is a service from Google Cloud that allows you to deploy and run your Apache Airflow. Airflow is this like the most popular, I think, framework, open source framework for orchestrating your data pipelines. It definitely demands and deserves to be learned separately because, as I said, it's a powerhouse of orchestration with a bunch of tools, a bunch of things to learn about it. But it allows you to orchestrate the very, very complex workflows in your data pipelines. It's not really suitable for low latency tasks. For that, in GCP, we should use workflows. But for those systems where a slight amount of delay is acceptable, the Airflow and Cloud Composer is a great tool. Next, I learned about the observability and two tools in GCP and in general, even in other systems that can be used for that purpose, which are cloud logging and cloud monitoring. So logging is like a such centralized service that where you can send the logs from all your applications running in GCP, or I think even if the certain program runs on premises, you can still send logs to this central hub for logs. And cloud monitoring is a way where you can monitor the health of your whole systems. You can set up alerts in cloud monitoring when a certain metric doesn't seem right to you. You can specify your own custom metrics based on the actual data maybe that is processed in the data pipeline. Yeah, it's like a very powerful system and you can customize it a lot, the whole alerting process. And it's also linked to the logs. Another thing about logging, which is very simple but effective, was that they mentioned the benefits of structured logging. So there can be a log where you just dump the text, which can be useful if it just says the pipeline run was successful. But for example, if an error happens, you would often want to have a structured log, basically like in a JSON, and you would put there, for example, the traceback of the error or any other context from the system that was processing this record that failed. And if you don't use the structured logs, the only way for you to analyze the logs, for example, for certain type of error or something, for certain data, for certain use case, user, whatever, would be to use some regexps to extract this data from the string. So it's not efficient, especially when there is another way to do it in a much more pleasant way, which would be to log it as a structured JSON. And then in cloud logging tool, you would write in the login query language, basically where this field of JSON equals to something, show me these logs. And it's a nice way to process vast amounts of logs much more effectively than you would do it in other way. The only thing that I didn't like about this observability part that it didn't have a lab, and I feel like it would be very beneficial to try to set up some alerting mechanism, custom monitoring metric or something. This is it. It was the whole course. It wasn't the best one, but it wasn't too bad. It gave a solid overview of batch data pipelines in GCP. Also covered these crucial concepts like error handling, data cleaning, and this data letter queues. A nice, not deep dive, but a few meter dive into the Apache Beam, the tool that I haven't used before and have like zero experience with. Now I have at least a certain picture of it. It's definitely not enough to go there and use Apache Beam to build some data pipeline, but at least I have a picture of it and the use cases when I should consider using it. And let's see, so far I'm honestly not very excited about Apache Beam because of its quirky syntax or something that I'm like not really used to, especially when there are other tools like Spark with Dataproc or like the whole other pipelines that you can actually build without Apache Beam or Dataflow. But let's see how it goes further. And like I'm not saying straight no to Apache Beam, so let's see. Maybe after some time I'll start learning more in depth about it. And other topics were great as well. So I can definitely say that all of them were useful. Overall, if I were to rate this course, I would give it a solid 6. And I want to reiterate, it's not a bad 6, it's a good 6. It's not 9 or 10 because it wasn't that great. I don't know, it's just how I feel about it. Maybe the text is not that perfect, just the perception wasn't that good for me after reading the materials. But the actual topics covered in this course were very great. They are the ones that we need to know as data engineers and know them pretty well. And the tools that were covered in this course were also very good. Just another point why not more than 6 is because I have this feeling that there should have been more labs here. I feel like these topics are very great, the technologies are super cool, but yeah, I would like just a bit more practice here, and especially in the observability and monitoring part, which is a very crucial topic, but yeah, there was no lab here. This was week 5. Thank you so much for watching, and see you in about 1 or 2 weeks with the next update. In the meantime, you can check out this video. Thank you again, and bye bye.